Assalamu alaikum. We all know that buildings are made of concrete and steel. We call it reinforced concrete. A good simple answer, why are we doing this? So the easiest answer I'll give you is the following, that the strength of the concrete compared to the strength of the steel is sometimes at least 10 times as strong as concrete. So we say n times more, depending on what is the steel strength. So there are steel strengths that are 8 times and 12 times and 15 times of concrete. So if I have a column of an area of 100, for example, then I can put on it a load. If I want to increase that load, I remove, for example, 10% of that area of concrete and put in its place 10% of steel. So what I've done is the 10% of steel is as strong as the 100 I have before. So I am getting a column now with twice the strength. So the idea of putting steel in concrete, in columns for example, is that the steel can take more than the concrete in strength, and we are every inch of steel or every centimeter of steel is equivalent to n times the centimeters of concrete, where n is the difference between the strength of steel and concrete. This is in columns. What about in beams? In beams, it's a totally different approach. In beams, the beam looks like this, and it has loads on it, so it will bend like this. And when it is bending, we get compression on the top and tension on the bottom. So if it is compressed, like if it is holding load here, this is a beam which is having load, so it will bend like this. It will have compression on the top and tension on the bottom. Now, the concrete is strong in compression, but weak in tension. Again, this is something which is strange a little bit. The steel has the same tension like it has a compression, but the concrete has compression 100, but the tension is only 15. So the concrete is much weaker in tension than in compression. So it is not like steel, which is tension, compression, the same strength. So when the concrete is in compression, it can take 100. When the concrete is in tension, it can take 15. So how can we solve this problem? We want the compression to be 100 and the tension to be 100. So we come to the tension side and we say we will add few reinforcing bars. And those reinforcing bars, as I said before, they will be n times stronger than the concrete in tension, and they will help take the tension. Actually, we reach in many beams to the following, that the beam looks like this. When we put load on it, we have compression on top and tension on the bottom. We ask all the concrete to take the compression alone in most of the cases, and all the steel down to take the tension alone. So we have, it's like a beam, it looks all concrete, but actually we are having a concrete on top and steel on bottom. In order for this concrete and steel to work together, they have to be, bonding together now. And that is the biggest problem of reinforced concrete, is the relationship between concrete and steel when they are together and you put on them forces. The concrete tends to crack, and the bond between concrete and steel tends to loosen up or have a problem. And this is the primary cause of steel deterioration. Now, many people do not know that it is natural for concrete to crack, because as I said, if the beam looks like this and I want the concrete to be in compression and the steel down to be in tension, I expect cracks here down. So that's normal sometimes. We try to minimize cracks. Why we cannot eliminate them in many cases, but we try to minimize them. And in order to minimize, why do we minimize cracks? Because we are afraid that the moisture will go into the concrete crack and reach the steel. And if the moisture reaches the steel, we are afraid that the steel will rust. Now, if the steel rusts, the steel tends to expand in its volume. So the steel's volume is 10 to 15 times if it is corroded than if it is not corroded. So that causes tension around the steel, which causes cracking in the concrete, and that is the reason we get cracking in concrete when the steel reinforcement corrodes. And I will discuss this in more detail in another video. Thank you very much.